Today, I would like to introduce you to the per-part machining feature in Woodsoft Optimizer software. As you already know, the Woodsoft Nesting feature processes many parts at once: optimal panel layout, G-code export, label generation, etc. The G-code file is then loaded into the CNC machine to machine multiple parts on a single panel. However, sometimes we need to machine parts individually. For example, using a horizontal drilling machine to drill cam-and-dowel connector holes, screw holes, etc. Or using a machine that has both horizontal drilling and surface routing capabilities to machine door panels. To do this, we need to perform two steps: export the DXF file of each individual part, use the DXF files of individual parts to export the edge machining file. Now we will perform step 1. Export the DXF file of each part together with the nesting result in the DXF nesting feature. You may wonder why we need to regenerate the DXF files, since we already have the input DXF files for nesting. The answer is that when arranging the panels, in order to optimize material usage, the software may rotate parts by 90, 180, or 270 degrees. The same part with a quantity of the second of may have one piece rotated 90 degrees and the other rotated 180 degrees. Therefore, we have to export two different DXF files for these two parts. To export the DXF file of the part together with the nesting result, we simply check this checkbox. The nesting result will then include an additional Part DXF folder. This folder contains the DXF files of each part, rotated according to its orientation in the panel layout. Note the convention here. The first edge of the part when feeding the workpiece into the horizontal drilling machine is the top edge of the label. Edge number 2 is the right edge of the label, edge number 3 is the bottom edge, and edge number 4 is the left edge of the label. That is, when feeding the workpiece into the horizontal drilling machine, we feed the top edge first, then rotate the workpiece counterclockwise to machine edge 2, then continue rotating to machine edges 3 and 4. If an edge has no horizontal drilling, it is skipped. We will compress the Part DXF folder into a zip file to prepare for step 2. Now we will perform step 2. Export the machining file. First, we have to configure the post-processor for per-part machining. Configuring the post-processor is similar to that in the DXF nesting feature. However, there are some differences. The first difference is that we have to choose the type of machine used for machining. There are 4 options. CNC with horizontal machining. This is a type of CNC machine that, in addition to performing surface operations such as drilling, routing, and cutting, also has additional tool slots for horizontal machining. CNC without horizontal machining. This is the common type of CNC. Choose this type of machine when you want to machine a single part on a regular CNC machine. Horizontal drilling machine with surface machining. This is a machine that can both drill horizontally and route the surface. For example, a door-making machine. Horizontal drilling machine without surface machining. This is the most common type of horizontal drilling machine. The second difference is that we have consolidated the tool configuration and the machining configuration directly into the post-processor configuration screen for convenience. The tool list now includes horizontal machining tools. The machining configuration now includes horizontal routing. As for the drilling configuration, there are still the same drilling modes as in the DXF nesting feature, the most common being the hole drilling mode. In addition, if the tool diameter is smaller than the horizontal hole diameter, you can choose other drilling modes from this list. After configuring the post-processor, we switch to the Export Machining Files section. Here I have pre-configured 2 post-processors, one specifically for running on a regular CNC nesting machine, and one for running on a horizontal drilling machine. I select the post-processor for the horizontal drilling machine. The surface machining configuration is similar to that of a CNC nesting machine. However, there is an additional machining order section. Here we can select, deselect, and rearrange the order of various machining operations. Since this is machining on a horizontal drilling machine, I deselect all other operations and keep only horizontal drilling. Next is the horizontal drilling order and the horizontal drilling code for each edge. By default, it first drills the top edge, then the right edge, then the bottom edge, then the left edge. With my horizontal drilling machine, the codes for each edge are 601, 602, 603, and 604. Your machine may be different. You need to ask the machine vendor or check their sample file. Next is the Y-axis direction for horizontal drilling. There are two options: forward Y positive, retract Y negative, meaning when the drill plunges into the workpiece, the Y coordinate is positive, and when retracting the drill from the workpiece, the Y coordinate is negative. Conversely, forward Y negative, retract Y positive, meaning when the drill plunges into the workpiece, the Y coordinate is negative, and when retracting the drill, the Y coordinate is positive. You also need to ask the machine vendor or check their sample file to configure this correctly. Next is the issue of horizontal drilling coordinate compensation. We perform horizontal drilling after the edge banding has been applied. If you name the edge bands according to the standard convention, edge band thickness multiplied by edge band name, the software will automatically add the edge band thickness to drill horizontally at the correct coordinates. However, if for some reason the horizontal drilling coordinates are off, you can enter a compensation value here. You can enter a negative or positive value to compensate. Then we select the DXF file exported from step 1 and click the Export Horizontal Drilling button. After a moment, you will see a zip file returned. This zip file contains horizontal drilling files corresponding to each part. The horizontal drilling file name is the part sequence number plus a random number to avoid duplicate file names. Let's open one file and run the simulation. You will see that it first performs horizontal drilling on the top edge with code 601. Here I have configured the drill bit to plunge into the workpiece twice to avoid damaging the bit. After that, code 602 is used for horizontal drilling on the right edge, followed by code 603 and 604 for horizontal drilling on the bottom and left edges. If we use a cutting tool with a diameter smaller than the hole diameter, the software will control the tool to route according to the configured drilling method. Please try applying this feature to your horizontal drilling machine. If you encounter any issues, please contact Woodsoft for support.